Hi everyone, my name is Arsum, and in this short video I'm going to walk you through this brain tumor classification project that I recently worked on. It took me somewhere from 7 to 10 hours to finish this whole thing, and all of the files have been pushed up to GitHub. And this is just to give you a heads up if you want to work on this project as well. The notebook is pretty self-contained, so if you go through it, it's going to actually walk you through, and you should be fine working on this. So first up, what are brain tumors and why do we concern ourselves with what they are? So, a tumor is really defined as an abnormal growth of tissue. So, brain tumors are just when you have abnormal growth of tissue in the brain, and each year, north of 300,000 people are diagnosed with brain tumors. And when you're dealing with a part of the body which is really sensitive, such as the brain, early diagnosis really matters a lot. And so the motivation behind this project is really to help people who work on the brain, neurologists, and really help them with early diagnosis and making sure that their diagnosis is correct. So in terms of project overview, the general idea is to have an interface, a user-facing interface, where any user can upload an image of a brain scan, and then they can choose between one of two models, and they can get a prediction on what kind of brain tumor it is. We're also gonna, as a part of this project, have a saliency map, which basically shows you what part of the image the model is focusing on to get its prediction. And then we will also use an LLM, which we give a prompt to have an explanation of the prediction by our model. So I'm going to demonstrate all of this through uploading an image. But before we do it, this is how the dataset looks like. So you have different images, and they're classified as glioma or pituitary or no tumor. And the dataset was taken from Kaggle. You have to do some pre-processing work in terms of resizing and just splitting the dataset. And then these are some results. By no means are these supposed to tell you something very specific, just to give you an idea of what it looks like. So on the right hand side, we have the exception model, which is a pre-trained model, so we repurposed it for our project. As you can see, the loss is decreasing and all of the other three metrics are increasing. So a general rule of thumb is that if your loss is decreasing, then you probably want to search for more epochs. So I stopped it at 5 epochs because it was taking time, but if you have the time, you can train it for 10 epochs and see if you can bump up your metrics. On the left hand side, I have a confusion matrix, which is just walking you through the predictions done by our CNN model in this case. The way to interpret this is if you focus on the 0 on the y-axis and you assume the 0 in this case is glioma, let's say. And what this diagram suggests to you is that our model is predicting 132 images correctly as glioma, and then 15 glioma images are being predicted as something else, which is 1, and then 3 are being predicted as something else. So that's how you read this confusion matrix. Because much of the data lies on the diagonal, it means we are doing a good job with this model. And now I'm going to go to the demonstration part, but just for future work consideration, you can train other models, you can work further on these models, you could integrate more things into the whole project itself. You can also work in better visualizations. But now let's take a look at how does this thing look like. So this is the interface, brain tumor classification. It's asking you to upload an image in JPEG, JPEG or PNG format. So I'm going to go ahead and we're actually going to upload this image. It's a pituitary image. It is PNG. So let's just open this over here. I'm going to move my face over here so you can actually see that it's running right now. And you can choose between one of these two models. So it chose the exception model by default, but we're going to switch to CNN as well. And this is showing you that the model gave prediction as pituitary with 100% accuracy. And this is the uploaded image. This is the saliency map. So it's showing you the regions of the brain that the model is focusing on. And then there's also an explanation using an LLM that was fed the saliency map and the prediction itself. So it's saying the model is high confidence, such and such, and it's explaining basically everything in technical words and know-how, right? So next up, we got 100% accuracy with the exception model. We can also try the custom CNN model that we worked on, and we can see what it gives us. So the custom CNN model also gives us a 99% accuracy for pituitary, right? So it's saying predicted class is pituitary. There's an explanation as well in this case. Interestingly, the saliency map over here is probably not doing a very good job. It is questionable why the model is looking outside of the brain in this case. So there's definitely more work that can be done on this project. But generally, the idea of a saliency map is to show you what parts of the brain the model is focusing on, right? So this is definitely something that can be improved over here. But essentially, that's the basic idea. You can upload any image over here. It's gonna give you a prediction. It's going to show you the original image, the saliency map, and it's going to give you an explanation for why it thinks its prediction is correct. So the whole thing is just to give medical professionals an extra hand in their diagnosis. And if you want to know more about this project, you can always just go to GitHub, or you can reach out to me. Thank you so much. Bye bye.